a better one next session. All right, so we're live, and please mute your phone. If if you're not speaking, please try to mute your phone.
Okay. I mean, but I thought we
Yes,
could.
Emmanuel.
I don't know when I joined the Google Hangout, there's a lot of echo when you talk.
Well, it's because you're hearing sound from two sources, right? So, that's the thing. Like, I'm gonna have to mute myself on the. If I mute myself on the TeamViewer meeting, right? Then Andy cannot hear us. So I'm gonna have to just, for the time being, basically just hopefully by 12 o'clock, and all of us can join. But Emmanuel, please join back to the Hangout and just mute the sound from the TeamViewer, right, on your end. Or at least exit the TeamViewer meeting, okay? Exit out the TeamViewer meeting. Cyril, yes, you can also exit the TeamViewer meeting since you are on the Google Hangout. Cyril, you can exit the TeamViewer meeting. And Emmanuel, join the Hangout and you can exit the TeamViewer meeting, so that's not a problem. Is that okay?
Yeah, sure.
All right, so I see that you've exited. Cyril still remains on the Google Hangout. So Andy will be the only one who will stay on the TeamViewer until he's able to connect to the Google Hangout. So you might not join the Google Hangout. And Andy, it's all your fault because you've made me fall in love with Google Hangout now. All right.
Okay, so I mean, looks like I missed. Whether maybe I'm doing something wrong here.
Can you see my screen?
On my phone, but not on the PC.
On the PC, you cannot see the SQL developer.
Yeah. Okay. I see what you're doing. Okay. I see. I think I see it now.
You see the SQL developer? Yes.
After taking me out, I'm going back into the Hangout and it says I'm not allowed.
You're not allowed. Okay, let me send you the invite again. I'm not sure why it wouldn't allow you, but I've sent it again.
Okay, I'm going to answer. It's sending me. Okay, it's sending me something that The thing is, I'm already on the hang. Okay.
Yeah.
All right.
I think you're in now.
Okay.
All right. So unfortunately, Andy exited for the TeamViewer, and my hope is that he can join soon. I feel terrible that I'm taking you guys through this, but honestly, I was playing back the video, and I think we have. Wait, Cyril, you joined again?
Yeah, I'm just going to. I was on phone, so now I just want to switch to the PC.
Okay, perfect. Right.
Yeah. So.
Getting a call from. Well, Andy's number is 6 something. He's this is not. Okay. All right. So. All right. So Andy, you're back here, right? Hopefully you can hear us, or at least you can hear me, right? It looks like you're having issues with the Google Hangout, right? I'm going to repost the link one more time for you, and this is the link, and it's LL. Email was that, right? LL something. There we go. Copy, paste. All right. That's it. Let's see if you can join. If you cannot join, that's okay. We'll have two sessions running in the background, and Emmanuel is fine because he's not going to get any echo. Um, and Cyril is good. Okay, so thanks for indulging me on this. You know, it's my hope and prayer that with this approach now, when the recordings are done, everybody can play it back and hear the entirety of all the conversations, even though for this session we may not be able to hear Andy. But Andy, if you want to hear us, right, you may want to join this. If you want to speak, you may want to join this 973, sorry, 718-362-6360. And then, sorry, I typed wrong, 718-362-6360, right? And the PIN number is 598-5488, right? At least when you speak through the phone, we'll be able to pick up the sound on the recording, right? So that's what we'll make do for now. All right. So I owe you guys some minutes this session. How was your reading? Cyril? Emmanuel, how was the reading? I gave you guys a link to read before.
Yeah, for me it was good. It was good that I got to a point where it was becoming abstract.
It was becoming abstract, okay.
Yeah.
All right. How about you, Cyril? Maybe did it. Cyril, can you speak? Oh, Cyril, you know what? I think if you can hear me, I think your whatever you connected to the microphone doesn't work. I'm getting it. It looks like your microphone doesn't work on your desktop, which is unfortunate. So you may actually also want to join back to. Yeah, he's on mute. So you may actually, if you don't resolve it, you may have to join back to the team viewer meeting, and you can talk that way. So you can have the two running at the same time, right? So Andy, are you there? I'm going to exit the team viewer meeting, and I'm going to start it again, okay? So that I can hear you through there. I think I just realized why that's not happening. Just give me one. I'm going to exit the meeting and start it again. The team viewer. So stay on the Google Hangout. Audio. All right. Okay. This is good. My meeting. 12 to 2. Okay. Hello.
Yeah.
All right. So I'm hoping that Andy can join this time around and I can hear him. Hey, Cyril. All right. Hey, okay. Andy. Andy, you good? All right. Now I can hear you through. All right. Perfect. Yeah, I really appreciate it. So I mean, I think I know what Cyril also just did. He's running the session on both his phone as well as his desktop. That's pretty smart. But you may get some feedback, right? So you may have to
Yeah, I'll
make.
just kill the one on the. Can you hear me?
Yeah, I can hear you. Just yeah, you may want to
All
maybe
right.
minimize. Yeah.
Yeah, I killed the one on the laptop, so that's fine.
All right. But you can still see on your desktop, right, the meeting, right, and you just
Yes, I
hear you
can.
just all right.
Yes.
Perfect. All right.
Yes, yes. So the I mean, pretty much what the little I'll share is that the um is for automation, and pretty much the program runs behind the user interface, and it communicates with the database, and it's how do you call it, uh, uh, programs or codes that would be written repetitively. It solves that issue with those kind of uh, processes. And also, it's not a standalone program. It runs just like a Gary and Beans. It runs alongside SQL. So that's what the general
Okay.
idea of what I. Yeah.
Okay. All right. Um. Okay. How about you, Andy? Okay. I was talking about if you got a chance to read the link I gave you guys regarding this PL sequel. Okay. All right.
And I
That's
think
cool.
it has a multiple. It can run multiple queries at the same time instead of
Right.
single. Yeah.
Emmanuel, are you there? Can you hear us okay? Emmanuel, can you hear us okay?
Yeah.
All right, cool. All right, so we're gonna go over the reason why I'm asking the question again was, I mean, last time I played back the video, right, and I said um, I may have to just take you guys through PLC call a little bit slow at a much slower pace, okay? So I want to use the first session, the first 15 minutes to go over some concepts about programming in general, right? Before I kind of dive into what where PL SQL comes in, right? Because um, I think Andy, you probably have a decent background, so you probably But for Cyril, he may need a bit of what we're trying to do. So um, here is what I want to share. Let's talk about this. Okay. So in general, right? If you think of any process, when we talk about computer process, it's typically, let's say a very basic example on your laptop. And I used this example last time, and I hope I can maybe now make it clearer to you guys. On your laptop, let's say you're concerned that you're not getting good backups, or you're worried that, hey, you have some data in some folder, and you want to make sure that every day gets backed up. Yeah, right. Absolutely. I mean, for me, my objective is, and this really the objective for most of these courses you take is we want to equip you with the necessary skills that when you pick up a document about PL/SQL, you can read through it and kind of navigate your way around it. Because for the most part, there's no way any one course is going to teach you everything you need to know, right? But yeah, but ultimately that's the objective. The objective is for you to get to a point where you pick up and you say, oh wow, there's a lot of information here now. Okay, I think I know what George was talking about here, right? And that's for me that's the ultimate goal. But
And then let me interject if you don't mind, briefly, if you don't mind.
go ahead.
Yeah. So besides this, besides the your tutorials, which is top notch, we are. What I want to know is what hard copy material or book should we use, or should be like a point of some kind of support for us to use, because there's so much out there, and you really know exactly what's needed on the job, real life, and we don't want to go, or some of us want to read, but then there's so much out there. Which one? Where would you point us to go to if you want to?
Now, that's a good question, and I would make sure that at the end of the course I give you a bunch of reference materials that I find very useful. Right. For hard copies, I actually, to be quite honest, I don't remember the last time I picked up a book about Oracle. Everything is done online now, so I don't really. I used to have, to be quite honest, I did have the Oracle 7, the whole documentation. The book was like, I was like maybe 2,000 pages, and now it's all PDF. So when you do go to the Oracle website, they do have a whole section about documentation. The stuff on the documentation can be a bit. It's good. It is a bit dense sometimes when I read it. It's like there's just too much stuff going on, right, in the documentation.
Okay.
But if you go here to docs.oracle.com, they have everything that you want to know about their products, right? So if you want to focus on the database, right? So you can come here and say, okay, this is the database, this is the, and then it has all these tutorials. You can go how you can install it. They have different ways of showing you the different things. So if you're going to be development, then they have this where they say, okay, you want to do a 2-day Java developers guide, PHP, or 2-day. This is actually a general developers guide, right? And in this one, if I was to download it, it's going to be a huge file. God knows how many pages there are in this, 293. But it would be very good to go through it and learn about other things. My hope is that once you're done with this course, you can pick up something like this and step through it, and it won't be too foreign, right?
Okay.
So that's a lot of stuff. Yeah, that's
okay.
I can paste this in the chat as a reference if you guys are interested in it. Doesn't hurt. Let me just paste it here, and then Google Hangout. Is there a chat session? Yeah, let me paste that in the chat session. Okay, so that's a link to some document that you can read. For our purposes, though, what I want to do, at least my approach is, is to say, when we talk about programming languages, right? Why they came about and why they are what they are is, it's because we want to automate things, right? So you go to any company, any organization, and you find yourself that different things, people are running different things, right? And if somebody doesn't show up at 8 o'clock on time, then it screws up everybody. So the idea of automation is, okay, somebody can write a program and then somebody can schedule it. And then we'll schedule it, this thing will run at 8 o'clock, and when it finishes, the next one will run at 8:30, the next one will run at 9:30, or just different times, right? That's sort of how automation sort of all came about. So in most organizations, you have people running batch files or running PowerShell scripts, or running corn shell scripts, or regular shell scripts, or you can run these days Python scripts, right? These are very common scripts that, or when I say common scripts, these are extensions. So an actual name would be something like run job.bat, right? That is running a traditional batch file. This has been there since Microsoft started MS, right? Microsoft batch shell or PowerShell. PowerShell is a very powerful, richer version. No, most systems are now using PowerShell scripts because they allow you to do more than a batch file. Then Corn Shell is for Linux. That's also, although you can have emulators that you can run them on Windows, you can have these two running on Shell. TY runs both on, this is Python, it runs both on Linux as well as Windows. So what I mean by that is, let's say Cyril has to do something, has to run, Cyril creates a script, and this script basically fetch data, it fetch sales data, right? And so it fetches sales data, and then Emmanuel also has a script that would read the sales data Cyril fetched, okay? Then Andy would say, I need to analyze, I need to, so okay, Emmanuel will read it, because Emmanuel will read and analyze sales data, okay? And Andy's job is to compare Emmanuel's analysis with another source, confirm output. What do I mean by that? In most systems, right, you need to, in most organizations, just like accounting, right, there's somebody who would review whatever somebody else does to make sure that we have sort of a single version of the truth. So what, if you have a process like this, Cyril may have written a script called Cyril.batch, and this batch file called SQL Plus, right? SQL Plus ships with every Oracle installation, and the SQL Plus is going to call a file called test.sql. That's literally how it will be set up. You create a batch file, and that batch file, within the batch file, you write code, and the code will call SQL Plus.exe, and the SQL Plus.exe will be using a SQL file that you will create. So an example of a SQL file we will create is like the homework assignments you've been doing, right? That's SQL files. And it will just step through it. Emmanuel too may have another thing. Emmanuel may say, I want to have, I don't like batch file. I want to use a PowerShell. But Emmanuel will say, okay, I want to call analysis dot py, right? Which is Python. You call Python script, and it will do its job. And then it will create some output, right? Maybe once the Python script runs and it finishes, it's going to end up creating output.csv, some CSV file, right? Then, Cyril, Andy would say, hey, I have this Python script. Is going to read the output.csv that Emmanuel has created. And literally, this is how organizations are, right? You join a team, somebody is responsible for the Cyril line, Emmanuel is responsible for his thing, and Andy, you write your piece. And the systems have to talk to each other, right? So you read the you read the output of CSV and compare with some source, okay? And then you would send an email to alert of any discrepancy. That's an automated process, in effect. There's something that right now maybe somebody's doing it manually, right? So you guys, you'll be hired to come in, and you guys are 3 developers, right? The first developer, okay, we divide the word up. The first guy says, okay, I'm going to create a SQL that's going to write some reports. And then that report, Emmanuel is going to also write his program and is going to consume the data of my test SQL, right? And then he's going to create an output. And then Andy is going to read the output.csv and compare it to some source, right? Are you guys with me so far?
Yes.
Okay. So where program PL SQL comes in is Oracle as a database, its primary responsibility is you store data and you can write queries to get results, right? So, but that's not the only thing we need in organizations, right? In organizations, there is often the need to have the ability to for systems to talk to each other, right? So just like Cyril will create, has a test.sql, which probably, outputs test.csv, for example, let's say, right? That's one system. So maybe Cyril, you are in some department in Jacksonville, and this is what you're doing. You're creating this test.csv in some folder. And Emmanuel says, okay, I'm going to write my PowerShell script, which is actually going to call some Python script, which is going to read test.csv that Cyril created and generate the .csv for Andy to consume, right? So now I'm adding more flesh to this, right? That's the sort of the nature of how most of the time when you join, the setup would be, right? This general concept is very important because when you join, some of these basic questions or basic structures, if you don't know it, you will find yourself asking very silly questions, right? Which would be not too cool, right? You want to make a very strong impression, right? And I only have Emmanuel's resume so far, by the way. I really would encourage Andy and Cyril for you guys to send your resume. What I'm trying to do is to review it, and really is the season of hiring is starting. For the next 2-3 months, there's going to be a lot of hiring. So, you know, I would like to just see it and see what I can add to it. And Emmanuel is the expert at it, actually. So, however, we can set it up so that you can at least, get some calls going and get a couple of interviews under your belt, right? So that you can be confident. All right. So this is how it will be set up. Now, the point I want to highlight is this test.sql file, right? That Cyril, for example, you put together is actually going to be a PL SQL block. And what I mean by that is within that, you're going to have a lot of logic that is very programming, I would say programming in nature. You're basically going to have logic to read something, add it, divide it, create some test files, and then read it. And you're going to have a lot of logic built within that, right? So that's where PL SQL comes in. Oracle saw the need that after they have created a database for people to be able to store their data and query it, it wasn't enough for developers to just have the ability. Developers wanted a way to be able to query, look at some results, do something else, put some data, and just keep massaging and moving data around, not just run one query and I just get my output that says, oh, here is a list of every employee and their salary compared to the average salary within their department, right? You want to do more than that. Okay. So before I get into that, what I was going to show you is last time I was trying to highlight this point, and I don't know if it was clear to folks. So let me open this. I'll open. And then one more. No, it's my drive. Hmm. I saved it on my. Hold on, where'd that go? There you go. Okay. There you go. Last time I was trying to highlight this point about programming, which is every programming language you deal with, you have to know three main concepts. There's variable declaration, right? Which is those areas of memory that you plan to use to do your computation, right? Then there's actually the actual stuff you do, within the code itself to massage your data, and then there's output. Effectively, that's what it is, right? So in fact, they'll call it, like, you've heard the term maybe a black box, right? Which is every programming thing is like this. You have and if this is too basic, guys, let me know. But I think you guys need it. That's why I'm going through it. Okay. Um, right. You have your input, and then you have your output. So they'll typically say this is like a black box, right? If you hear the people use the term is a black box, which is basically saying you put something into some black box. The black box has all the code to process the inputs you give into it, and it's going to give you an output. Those are the very three basic structures of any program you're going to write. Okay, when you talk about programming language, whether it's C Sharp, VB, whatever it is, they all follow the same structure. Give me some input, I'll do some operation on it, and I'm going to give you an output. That is programming 101. Okay. PL/SQL is the same idea, it's the same construct. So last time we went there and I said, okay, if this is our RAM, right, which is your computer's memory, right, that is random access memory. It's huge, okay? But for the sake of argument, let's assume this is all you have. Then if you want to do any operation, the computer has to manage, anytime you want to store something, it's going to have to figure out a way to store it on the RAM, right? So if you want to do 1 + 1, it's going to put maybe 1 here, it's going to put a plus sign here, it's going to put 1 there, right? And I'm going to just type plus, and it's going to say 1, and then the output is going to be 2, for example. So from a storage standpoint, we say this is X, this is maybe Y, this is Z, and this is output. These are your variable names. Now, it's effectively used up, about 8 cells to do that, right? So again, the object or the idea of programming is that you say, hey, I want to do something, and you're going to tell the programming language platform is going to interact with the RAM on your laptop or your computer or your server, and it's going to do that operation and give you an output, right? When I was programming, I wish somebody had explained this thing to me, because it's the very basics of why efficient programming is important. Because if you understand that this thing is finite and you cannot, you have to think about how you're using it. Because right now, if you've done this, all right, then I only have this left. I only have that left. So imagine that you have a big program and it's doing so many things. What is going to happen here? We're going to run out of memory space, right? And people say, oh, my laptop is slow, or this is slow. Yeah, because you're running too many programs, right? When you run too many programs on your laptop, then the thing becomes slow, right? Now, this works in conjunction with your CPU, but I'm not talking about CPU here because that's a whole separate animal. But from a programming standpoint, your input is going to give you an output, right? So here, our black box is the plus sign. The plus sign is to the operation. There are two inputs, one and one, and it's going to be fed into a black box, which is called plus, and it's going to give us an output, which is two, right? That is the fundamental structure of any program that you're going to write. Any questions?
No.
Okay. So with that background, right, I'm going to walk you through what we did with the PLC call and then try to jump through it. Just do a quick review. We jump through it. Now, we talk about the history of it and all that good stuff, right? The operators, arithmetic operators, as we talked about, is pretty straightforward, nothing complicated, right? The key point that I want you need to highlight or remember is that, yes, basic plus, minus, multiplication, arithmetic is going to, it gives you all the options to do that. Your job is to remember what sign it is. Plus, everybody remembers minus, star, division, and then this is the power sign, right? There are, we can go for an interview, quite frankly, and don't be surprised if somebody asks you, like, what's the order of precedence of arithmetic operators? And don't belittle it, because you know what? In my experience, oftentimes, most of the production bugs you see is because people don't pay attention to details like this. So these days, yes, you go for an interview, and the guy who understands this stuff very well or can remember it very well is the one who will stand out. Because management, you take down 10,000 production issues and you drill down, it will always come down to something very fundamental that somebody missed. A division by zero, for example, right? It was missed. An NVL, like a null value, one plus null. And it's like, oh, dude, you know that if it's null, one plus null is null. So you should have asked, what are you supposed to do in that case? Right? Now you've caused a production outage. So understanding this board mass, right, which is what we use, this is board mass, right? Andy, you can see the screen, right? I have to periodically check on you because you're on TeamViewer, right? Okay. So, sure. Well, so that's a good. So every programming language has a certain structure or format, right? So I'll just make this general point. I think, Emmanuel, I've told you this before. Programming language is nothing different than what you and I are used to. French is a language. Portuguese is a language. English is a language. Latin is a language. All of them, you can say the same thing, but it will just be done differently. Okay? I don't remember my French very well, but what time is it? I think is what, Keller or Teal or whatever it is, right?
Let me see.
It's not the same. What time is it? Right? But I'm going to tell whatever it is. PLC code's rule of assigning a value to a variable is this structure. So let me go back to this one here. All right. So in PLC call, if I have a variable, what was that one? Oh, there it is. If I have a variable, right, and the variable is called variable salary, right, and I say this variable salary is going to be a number, right? By the number, and within the organization, nobody gets paid more than 20 million. So I'm going to use, let's say, it's a number of up to 7, right? Because nobody's going to get paid more than whatever. This will store up to 8. Let's say 8, right? Because if 20 million is what? 2 times 10 to the power, yeah, so 10 to the power 7. So, right? So if I have V salary, I have declared this variable. Then if I want to assign a value to it, I'll say something like V salary, colon, equal. That's the convention in PLC call. Let's say 45,000. That is a convention, right? That's how you assign values to variables in PL/SQL. In other languages, Python, and you see that they also be a little different. So in actual fact, in programming, once you learn one language and you understand it very well, learning the other languages are not that difficult because they all follow the same structure of input, black box, and output. And the only thing you have to understand is how each black box really works, which is how does a variable get assigned, for example, in PL/SQL is this way. Maybe if you go to I don't know Python, it's just a matter of just saying this, right? That's it. There's no need for a colon sign. PL/SQL standard is you have to do the colon and equal to, right? I don't want to get into the mechanics of why you do it that way. But behind the scenes, when you submit your program for a database to execute, it has to parse out what you've given to it and then translate it into a set of actions for the computer to execute, right? So every what they say compiler, right? Although PL/SQL is not a compiled language, every program, you and I, all of us can actually write a programming language. It's almost like you go to secondary school and we have to make up our own language. Like, hey, this is how we talk, right? So we decide that if I want to insult somebody, this is what we're going to say. But just the four of us will understand it. Everybody else wouldn't. If you join the clique, then we'll explain to you how we insult somebody, right? So PL/SQL as a structure says this is how we assign a variable, a value. This is what we're going to do. We declare a variable this way, right? And then we assign a value to it this way. That's their rule, right? And Python will say, I do it differently. C# will say, I do it differently, right? And it's become a preference. So really, you join any organization and you find out that, oh, why this guy's using C# or Java or this? And you realize oftentimes it's the preference of the manager or the people who started it. And it's not, there's no reason why it's just because they started that way. Right? You join the clique, now you got to learn to comply with them, right? That's what you learn in SQL. But SQL, ANSI SQL is universal. The concept and the structures is the same across all databases, ANSI SQL, right? But PL/SQL is very specific to Oracle. I mean, there's T-SQL for the SQL Server guys, and they have, every language seems to have some procedural language equivalent that they will hook into their SQL that you use to query for your data, okay? So going back to this, yes, this is saying that I have a variable called salary, and I want to store within that variable whatever that current value that you are currently storing there. Then I want you to multiply that by this and give that. Now, this expression obviously is silly because really this expression can become, instead of doing this, you can just say 1.05 times V salary, right? It's just math, right? It's just ways of doing this. Now, this actually how you get performance issues, right? In your code, is that this thing is actually takes up more memory to work with than if you just said 1.05 times V salary. But that's not the import of this session right now, right? The point of it is, if you have a variable and you want to assign a value to it, you have to put the colon and the equal, and then you follow with whatever expression that you want to use to derive your value. In my case, I just wanted to put a hard-coded value of 345,000 in the demo. I said I want 345,000, but I could easily well have said, guess what? I could have said, oh, it's V underscore salary times 1.05, which is basically 5% more of whatever current value you're storing. And this is a very interesting construct within programming, right? Which is, I have a variable V salary, and I want to assign to it whatever it currently holds times 1.05. That's what this expression means. Okay, same thing here. I have a variable is V salary, and I want you to assign to it. You're telling the programming, the compiler to say, hey, take whatever value you currently are storing there, and then multiply by 0.5 and add it back to it and store that back to it. So this operation, you guys are not going for a pure algorithmic class. I don't want to worry too much about that. But it effectively you're doing something like you're saying, I have V salary, okay, and let's say currently V salary has 100,000. What you're saying is that V salary, I want you the computer to now store this 100,000 plus 100,000 times 0.05. Okay, which is the 5%, which is 105,000. That's effectively the expression that you're seeing here, right? I mean, I just literally wrote this expression in Excel. All of these cells you see in Excel, they're all variables. You can store anything you want in them, right? And behind the scenes, when you do this Excel thing, it gets translated to things like this behind the scenes, this sort of structure. Okay. Similarly, says, okay, Andy, okay, you asked the question. So what do you think this expression is doing? The other sound output is better. Will you join the Hangout or? Oh, I don't know what happened there, but do you see the expression I want you to try to explain? Okay. Yeah. Yeah, effectively that's what it is. It's like you have three variables, right? So if it was Excel, I mean, I'll use the Excel example. Maybe that probably helps explain it better. So in Excel, let's say you have V, what do we have? We have three of them. We have V salary, V sales after tax, V wage, and V tax. Okay. So you're gonna say something like, we have V. Let's say your V tax is 5%. Okay, and then you have your V salary is 100,000. Then you have your V salary after tax. Okay, so that expression, if you're doing it in Excel, you say, all right, let me go and pick whatever the person is making, then I'm going to subtract whatever they're supposed to pay in taxes against their, right? So their salary after tax is 95,000 because they get taxed 5% on whatever they make, right? But effectively, we are assigning to the sal after tax, this variable, whatever this expression is, right? So in fact, if you look at it, if you're used to Excel programming or manipulating data in Excel, there's a lot of similarities and parallels. Okay. All right. So we talked about the BODMAS. That's all this was about, right? And then we did the comparison operators, right? The comparison operators are what? Every programming language also has it. I need to compare two numbers to see which one is bigger, which one is greater. I want to see which one is less. I want to see if they are equal, right? And different programming languages may offer one or two special comparison operators that is local to them. The whole idea being, okay, that's how they will stand out from their competitors, right? Which is to say, you know, why would you, I don't know, why would you buy a Toyota Camry as opposed to what a Nissan? What's that called? Nissan. What's that? What car does it compete with?
Is it Ultima or
Ultima, yes. Thank you.
Ultima?
Nissan Ultima, right? So why would you buy this over that, right? Yeah, you may say Toyota has some features that you like, and but they're both cars. They take you from point A to point B, right? Yeah, they have chairs, they all have wheels, they all have steers, they have the same thing. But you prefer one over the other. Programming languages are the same in the sense that they all do the same basic stuff, but some have features that allow for easier development. As in, you can add more features to your existing infrastructure than others. PL SQL is actually is very limited in that sense. That's why oftentimes you can never really use PL SQL on its own to fully develop any system. You have to include Java or C# or Python or anything like that to really fully automate a system, right? So these days you'll find out that they look for things like they say, I want a full stack developer, right? A full stack developer, if you look for jobs, is somebody who knows SQL, they know doesn't know SQL, they know Python or Java or C#, and they know some web programming too. Then because they kind of have sort of the whole stack, the database layer, the middle layer, and then the front layer, right? And those guys are really in demand because a lot of companies are getting cheap with it. They don't want to hire pure developers, and then they want to hire people who have the two. And that's why, like something like Tableau, right? If you know it and you know SQL, it actually makes you very marketable because Tableau provides both the front end and the middle, right? It doesn't do much of the database work, but it's really more of the front end and the middle. And your ability to write SQL to talk to the database to get data is all you need, right? To kind of call yourself like a full stack developer. Okay. So we did talk about comparison operators, and then we talk about the string concatenation, right? So again, this operation concatenation is very unique when you have two strings, meaning if you have two text fields and you want to join the two, then you have to do the concatenation, right? And I did talk about, the review, this date operators, which saying that, okay, if I have two dates, and if I want to find out, if I want to store into the variable tomorrow, I'll say, take the current date and add one to it. This is basically going to do this date plus one, which is today plus one more day, right? All right, so that was all review, right? And
so quick question. So with the V, pretty much it just stands for variable. That's why it comes before whatever. Yeah,
it's not. It's a good standard. You join teams, and in some teams, right, the standard they use, and every programmer has actually that right. Okay, so you see some programmers, whenever they are declaring variables, they will say V underscore. Somebody will start with underscore V underscore. Somebody will just say, they'll do camel case and say my variable, something like that. Others would use, but it's important as a developer to pick one style and stick with it. That's my recommendation. The good developers you see always pick one style and they flow with that because it's consistent. When somebody's reading your code down the line, they know that anytime they see that, it tells them that it's a variable, right? It's a variable that you've declared. So just pick one and be consistent with it.
Okay.
Now, for anything to call itself as a database, it needs to have the ability for you to write a query. It needs to store data, right? For any language to call itself a programming language, right? It needs to give you, the developer, a set of types that are standard. And what I mean by that is, it's not the job of a developer to figure out how to store a number, how to store a string, how to store a date, and all that. The programming language, if it's C Sharp, if it's Java, if it's Python, they all should be able to provide those sort of basic level of data types to you. Because yes, anytime you're dealing with data analysis, you're going to deal with data from so many different sources. I mean, I'm sure you guys, when you give somebody gives you an Excel spreadsheet, you see that, oh, this field has numbers, this has, text, and this one has, whatever, decimals, this one has percent sign, this one. These are all different data types, right? So every programming language fundamentally will give you a set of standard types, right? Or basic types that you can use when you are storing your data. Because if they didn't do it, and which was the case in the 70s and the 80s, if you're writing a program to do a basic addition, it was like 50 lines, okay? When you can just do it today in just one line, right? So because they abstract most of that boilerplate now from us, which is, you don't have to worry about all the internals, right? It is all sort of abstract to you. So they call these languages 3GL, which is third generation languages, in that you don't have to worry about how you allocate memory and where it's stored and how you recover it and all that good stuff, right? Of just saying that I want you to store this variable and it's a number. And the programming languages platform's objective and responsibility to go and talk to the RAM and find the necessary space for you. Okay. And I make this point because when I started programming, I started with 3GL. And so I never really understood the history. And the more you do it, the more it's important to understand the history, because they say, like, if you don't know your history, you wouldn't know where you're going, right? So you have to really know the history of some of these things. It'll come with time. So, all right. So that's how you declare a variable, and this is the different, structures that, you talk about. The standard types, number. For PL SQL, you have number, char, varchar2, boolean. These are all used to store different data types. So if I have anytime I'm dealing with numbers and I don't really care about performance, I'll just use the number type, right? This guy. But if I care about performance, I will use number types which are much more specific to the data I'm dealing with. For example, if let's say we are going to be storing money, right? Where, you don't want to be storing numbers with points 1, 2, 3, 4, 5, 6, 7. It's such a long, right? You want to be able to say store very specific things. There are different data types that you would use. And sometimes we care about something like pi, 22 divided by 7. It goes on forever, right? So you have to have the right number data type to store something like pi. And these decisions, you make them as you look at the data that you have. It's okay, this is because of the nature of this data I'm dealing with, I have to use a date type or a timestamp or a raw or any of those sort of things, right? For the most part, most programming languages that you would do, at least in my experience, number, varchar2, PLS integer, date, and timestamp are guaranteed. These other special data types, LOB, right, large object types, they are becoming more and more important, right, in today's programming, because today, because storage is cheap, you have tons of data. So you can actually have a table, right? And one of the columns in the table is actually storing files, right? So can you imagine like the employees table, and then the first column is employee ID, the second column is a file that links to the employee's history and their details. You can actually have data like that. So in such a case where the data is loaded that way, you have to start using B files and B lobs and NC lobs and C lobs. These are special data types, character lobs, to store very unique set of data that is not very traditional. Okay. Then there is what they call composite types. Composite types, remember I was saying that if you have a record in the table, right? Let's say the employees table. Where is that one? Right? And this guy is an employee, is a record. Is made up of 5 columns. That's a composite type, right? It's composed of multiple columns. So in such a case, Oracle PL/SQL, and this is actually one of the nice things about it, gives you the ability to store such data as one unit. And so they call them composite types. You can also use them to create your own types of records. And we'll get into that later, but that's a topic for another day. Okay. But the essence of it is this. If you want to declare a variable with the same type as the database column, then you use this very special construct that Oracle gives you called %type. This one is I can't belabor this enough. Anytime you are programming to deal with data where you're reading data from a database table that you've created or that you know of, you should always use this structure. Always. So even if you know that the data is of number type or is of varchar2 type or a timestamp type, don't declare the variable and say, oh, I know it's going to be timestamp. Don't. Defer it to the database and say, hey, I want to declare a variable and I want you to give it the type of this. So for example, I want to declare a variable called title. And the title, instead of saying that it's varchar2, I'm going to say, go into the books table, look at the title column, and tell me what type it is. And that's what I want the PL/SQL to use. The importance of this is that then you don't make assumptions. So sometimes you look at data and say, oh, I think it's a number type. And then you're like, oh, no, it's actually a varchar. Because guess what? You didn't take the time to go and actually look at the data definition, go to SQL developer to figure out, oh, the employee ID is actually a number. Oh, I thought it was a text field. I thought it looked like text. No. You have to look at it and figure it out. But if you don't want to do all that work, then it's a slightly longer approach, but it's guaranteed to give you the correct data type of the column that you are trying to read and process in your program. Okay. So they give you an example where, let's say, for example, you know that, okay, in your program, there's a commission field, and the commission is basically a number with 2 decimal places. So this is what it means. It's going to be, the most you can store here is 999.99, right? Because it's up to 5. Okay. So you know that, okay, I need to store some rate, and it's 12.5% or whatever the amount is. And then you declare a variable and you say, well, go and grab whatever I've said above here. I want you to repeat it here, right? Because in fact, you're saying that I've declared this once. I don't want to make the mistake of redeclaring this variable and saying there's a text or something. It's a commission, so let me just pick whatever I said before and just use this type. Okay, it's a very good way of being consistent in your program, right? So that if you define a variable in the beginning of your program, and let's say it was a number, and then you're writing your code, you're like, on line 200, you don't know what you wrote at the top. You just say, well, it's V, whatever. I know it's a V commission. Let me just get the type of it, right? Because yes, you'll be running programs, and it's like sometimes it's going to be 2,000 lines of code. Okay. I was so happy when I wrote my first program that was about 1,000 lines. It was the most excited day of my life. Well, the good thing was that it was exciting just because the program worked. But before I got
this
to that
one
point,
what was it banker to banker strategy you adopted? With the papa.
I pray and hope that all of you will get to that point, and then you can give me a call and say, George, man, I wrote this program. It was like 1,000 lines, and I ran it once, and everything worked out perfectly. I think the most day you do that is when you know you've arrived. Maybe 1,000 lines is too much. I'd say maybe 200 lines, because to write a program 200 lines is still a lot of work. Anyway, so uh, in addition to using the type, right, option that PLC code gives you, they also have the row type. So just like you were saying, sometimes you'll be dealing with the entire row, not just one column in your table, right? So it does give you the ability to declare a record and say, hey, I want you to declare a variable. The variable is going to store, each, you should allocate enough space to store a record type. So what it would do, for example, is if you do that, right, and you say, hey, I want to store v rec employee, and I'll say go to the HR dot employees um, table and get percent row type. Okay. And what it will do is then once I do this, it's gonna, when it's executing, it will always pre-allocate enough space to store the typical record and how it looks like, right? That it will have the employee ID, the first name, the last name, the salary, and all those fields. It will take care of that memory management for you. Okay. All right. So without getting too much, I wanted to kind of show you guys some of the examples so that you see this sort of in action. All right. So we'll come back to this. Let me share. Let me stop presenting this and share the SQL developer. I got to do it in two places now. So okay, there we go. And let me go to the Hangout and change what I'm sharing to application window. Okay. Can you all see the PLC code develop? The PLC code. The SQL developer UI, Oracle SQL developer.
Yes.
If you'll indulge me, I need to take a quick coffee break.
Okay.
If we can touch back, just touch base within the next 2-3 minutes. Okay.
All right.
Alrighty. Um, Alrighty then. All right. Is everybody back?
Yeah, we're here. I'm here.
Okay. If I say your name, you say present, sir.
Yeah.
And
Roll
Emmanuel,
call.
Emmanuel, Emmanuel. I don't know if Emmanuel's back. How about you, Andy? Okay. All right. Cool.
Oh, okay.
Everybody's here. All right. Well, I just for took a break. I wanted to just at least show you guys like what we're talking about, like move from the abstract and just show one example, and then we'll go back to the abstract, go back to the analysis a bit. Okay, so um, let's see. Let's connect to database. So here's what they will call an anonymous PLC call. Anonymous PLC call is nothing but a SQL in which you write and you don't give it a name. So what a PLC call you write, you don't give it a name. So what that means is this operation that is going to do, you've not given it a special name that you can call it by and say, hey, anytime somebody calls um, a program, it would run, right? They have to call this entire thing. So there are ways for you to encapsulate or put, wrap a bunch of commands together into one sort of public name that everybody can use. And when they call that, it just does it. Okay. Um, and they actually are doing that in this code. It's just not. I'm not highlighting it yet. So let me just format this a bit so that it's clean. Right. So the very first thing when you're doing it on your machine is to put this instruction on set server output on. Right. This is basically a directive so that whatever you execute and you print out anything, whatever you print out will show. Okay. So the structure of an anonymous SQL is you say declare, and there will be a begin of the code and there's an end of it. And to execute, it would have to have this semicolon and then this forward slash at the end. Every line of the code, whether you write would have to end with this. So every complete line. Now, in the interest of highlighting it correctly, I would show you this way. So, Emmanuel, are you there? Oh, we lost Emmanuel. Maybe you can still listen on the Hangout. What do you guys do on the Hangout? Okay, so you guys also see the same thing that Andy's saying.
Yeah, I see your screen too.
Sorry. Okay, so Emmanuel, I think had asked a question in the chat. Towards the end, I'll try to answer some of these questions, and maybe as we go along, you may see a different. I may answer your question if I don't see it on the chat. So I'm going to put the chat next to this. All right. So what I'm basically saying is, if you look at this, the structure of PLC code is declare, begin, and end. The begin is saying I'm about to do some work in this block and I'm going to end. But just like in SQL where we can do onions within onions or nested queries and inner queries, in PLC code, any begin end, this begin end can actually be inside another begin end, which will be inside another begin end. You can have a lot of layers of them. Okay. So that very structure of SQL where you do select from where, right? And you can do nesting upon nesting of them. That same structure is available here. Okay. This is a very simple program. And all it's going to do is just output the numbers 1 to 10, and it will continue when I is equal to 5, meaning don't print out anything when I is equal to 5. So if we highlight this and we execute it as a script, it should give us this, right? So this is the output, right? So here it says there's a variable called I, okay, and we're going to start from 1, 2 dots to 10. That's just a pure SQL way of saying I'm going to loop, I'm going to repetitively doing something. But every time I do the first thing, the counter increase. So the counter should start from number 1. So I have the counter is going to be tracked by this indicator called I, or this variable called I. So the structure is for I in 1 to 10, loop. Loop is a very common construct in every language. You're basically saying, keep going until I tell you to stop, right? So with that comes the concept of an infinite loop, which is very dangerous. When you have a program that gets into an infinite loop, it never exits out. It takes up all your machine. In fact, that's one of the ways hackers bring down servers, is that they will send you a program, and when you click on it by accident, it will just shut down your computer because it gets into an infinite loop, which takes up all the CPU of your laptop or your server, and you can't do anything else. And you can do that to yourself in your own programming experience. if you don't correctly put the exit conditions within your loop. Now, so the structure says for I in 1 through 10 loop. This is a very important structure in programming. In PL/SQL, it says continue when I is equal to 5. So what happens is when you start the program, it will start with 1 in this way. Is 1 equal to 5? No. If that's the case, then just print. The command to print this I equal to 5, the command or the structure is this. Now dbms underscore output is a package, which is a bunch of functions that Oracle has put together that they've given to us. Like I said, anything that calls itself a programming language should give you a bunch of standard features, right? Because you don't want to be the one to try to put all that code or logic in there. That's the nature of programming, is that every day somebody is programming something. We don't go back and reinvent the wheel. So in Oracle, yeah, some people were like, oh, we need the ability to print. All right, let's put the code together to do it. And then once the code is working, let's package it up. And then we call it this big package of database management service output. That's what this means. So somebody gave it a name to output something, right, on the screen. And within that, they have a bunch of functions. One of them is called put line, which is just write on a line. And it just takes an expression, which is a string. In this case, you are concatenating two things. You're concatenating this I equal is your string, and you're concatenating with whatever value I is. So you start with for I in 1. So we start with 1, and we do a check. Is it equal to 5? No. That means we should just print this, right? Then we check. It doesn't even come here. When would we end this loop? It will end the loop when we hit 10, because we have told it very specifically in this structure that start from 1 and end when your eyes are 10. The beautiful thing about this approach is that you, the programmer, is not responsible for incrementing the counter, right? You are not responsible for it. PL/SQL itself will do it for you. And I'll explain that later when we get into the other sections of it. But the point of it is that your ability, you can write loops in 3 or 4 ways, right? This way is one way that you can learn. Here, you never have to worry about the exit condition, right, out of the loop, because every loop has to have an exit condition, at which point the computer knows to stop whatever it's doing in the loop and get out and do something else, right? Otherwise, it will run on forever, okay? This continue structure is basically saying, all right, so now I is, let's say, 2, it checks, it's not 5. I is 3, it checks, it's not. I is 4, it checks, it's not. But when it's 5, it says, oh, if it's 5, just continue, which means don't do anything, just go back and go back to the beginning of the loop and start again. Start from wherever you left off. So we're at 5, all right? You don't want me to do anything, I'll move to 6, right? And sometimes when you're programming, you find that you need to do that, right? You may be going through a list of names, And you would say, well, the instruction is that if you meet a name that starts with A, don't do anything. Only focus on names which don't start with A, right? That's sort of a practical scenario, I guess, right? So if you look at the output, it will say I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 6 because of this very line here. We did not want this part of the code to execute. So as soon as we checked, we just continued, as in we don't even come to the next line. We just go back here, increment, and then we continue going forward. Okay. So this is what they call anonymous PLC call. The structure is declare, begin, and end. And as I said, this begin and end can be part of multiple. It can be nested as many levels as you want, just like we're doing with SQL, where we do nesting, right, of the SQL, inner SQLs and stuff like that. All right. Any questions on this before we go back to continue with the tutorial? Is it very clear?
Yes, so far it's to me it's fine. I had a issue with the print, but I think I understand. But print pretty much means print out the report that is you're trying to generate, or is that what it means?
This is really to print to the output. So in every language you encounter, when you start a program, it would always output to some screen, right? A terminal window.
Yeah.
Right? And you can redirect the output from the terminal window, for example, say to a file, right? For our purposes now, we just want to just output the output of our program. We wanted to show it here in the terminal window, right?
Okay.
Let it do magic, right? But this thing that is printed it out here, as we go along, we may actually we may need not to output on a window. We may actually want it to put it in some file that Emmanuel can use, and then Andy will then use what Emmanuel just did. Okay. So
okay.
Let's share. Let's share mine. Again. And Andy. All right, now I'm going to go back to the notes, all right? And then we'll try to wrap it up in the next 45 minutes. I mean, we'll just do the project in the last session, because there's just too much here that I don't know if I really want to make sure you guys can understand, because the job market itself now, I think it's decent. Like, it's still pretty good. What I mean by that is this cycle of it, when you go for interviews, there will be a lot of really good guys out there in the job market, because there are folks who are getting their bonuses and they hate what they got, or they're going to hate what they're going to get, and they get pissed off and they want to leave, right? And then there are folks who just have been stuck on the same job for a while and they feel like the economy is good, so they want to change. So there will be a lot of people out there who may have a lot more experience. So you need to make sure that you're on point, because you may be competing with quite a few good people out there. But once you hit around April, May, June, around that time, is the cream, so to speak. I think the people who have a lot of experience, right? They would have gotten jobs by then, and then they would not be in the system. So right now, it's just, if you just get something right away, great. But just to set or anchor your expectations, it would be more like just go and get a couple of phone interviews and get comfortable, right, with the set of questions and how you yourself is responding, right? And then we'll play by ear from that point. All right, so we talk about type and we talk about row type. There is collections, but I don't want to talk about collections yet. I want to just go straight to this control structures. Then we'll come back to collections later. Now, control or conditional structure is nothing but basically saying if else, right? in any program that you write, you have to do some if else every single program because that's the nature of it, right? Somebody is going to give you a set of rules and say, hey, if this person does this or if this person comes from this health insurance company and they are part of this group, then you're going to do this. If they are from this, then you're going to do that. So that's all, just like we speak English, if this, that, if else, that, right? So, and with if else, there's a structure, there's an equivalent structure that you can do with case, right? So this is hopefully self-explanatory, which is saying that if you have stored a salary value in it is greater than 40,000, then I want you to take some action, right? So here you put some code, itself, an actual code. So code could be simply mean DBMS output put line something, right? Which is you are overpaid, for example, or else if the salary is this, you are way underpaid. Else, I don't know what to say to you. Right? So this is the structure, if else, and you can literally replace that with the equivalent case and case structure. Now, one thing that you always have to keep in mind, if you ever go for an interview and that comes up, is with case. I guess I sent you guys on a WhatsApp. Case you could be dealing with a range comparison or very discrete comparison. This one is a discrete comparison, which is you're saying check the grade. If it's A, then say that is excellent. If it's B, then say it's very good. If it's C, right, you're very discretized. It's very specific scenarios that you're looking at. But if you're interested in ranges, right, where you say, well, if the grade is A or B or C, I mean, that one you can actually do it still with this approach. You say when you say case when V grade is this, then do that. All right. But with still the number comparisons, what you have to do between a range of numbers, then this approach won't work, right? So there's two case structures that you have to know about. Any questions about that?
No.
Okay.
Yeah.
No, I know you had asked a question in the chat. I'm checking what you asked in the chat where you said, what is the difference? You're more light in a range. Okay, so, all right, Emmanuel has a question about range. So let's see. If, okay, let's do that here. You may be interested in this, right? So you may have some data and I may be interested in, here's some scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The point of a discrete change is you say, hey, if the person is 1, you say A. If it's 2, you say B. If it's this, you say C. Right? D, E, F, G, H, I, J. Right? In each particular instance, you are assigning something to it. Now, these don't have to be necessarily different per se. As a matter of fact, all of this could actually be A, right? But you are saying that check for each of these values. However, sometimes we are interested in, somebody may say, well, if the person's score is between 1 and 5, then they got an A. And if it's between 6 and 8, they got a B. If it's between 9 and 10, they got a C. It's kind of a reverse, but here the scoring is a bit on the low side. Right? If you get 1, you get an A, actually. Here you're doing a range comparison because you're saying that if the person scored between 1 and 5, you're going to give them an A. And if they score between 6 and 8, you're going to give them a B. That's the range comparison that we're talking about, right? So if you're doing SQL, you say, well, case V score is a case when V score is between 1 and 5, then DBMS output dot put line. Okay. something like that, right? Let me see. When Let me actually line this up correctly so that you see it in SQL. So you see, if you do like case first, you say when this, do that. Um, when in this case you be when v score between 6 and 8, then DBSMS output B. And this is very easy. So you say else DBMS output print line B. Okay, and then you say end. Right. Basically, you're saying that you compare, you're assigning values based on a range of numbers, right? That's all that you're talking about here. Are you clear there, Emmanuel? Okay. Moving on. Let's see. So we've talked about the case, and then we just did an example where I actually use this code to highlight, right? So I use this for loop construct to highlight, but you can actually use this a version also, right? So let's quickly use this version and walk through it. Okay. Oh, and I have to share my SQL developer screen. Okay. Andy, can you see my desktop? Okay, hold on. Did it come up? Hold on, let me just. All right, how does this? You see the PLC? Okay, good. All right, me then share. Okay, so hope everybody can see it, right? So this structure is effectively sort of the same as the one we're working with a for loop. Again, this is all about controlling your program and how it's executed. So in this example, again, is an anonymous SQL, right? I put the set F0 output on at the top just so that we can get the output on our screen here. The declare is very important because it tells you that this is an anonymous SQL block, which is it's not named, but it's going to do some work. And the structure is begin and it's going to end. So at a minimum, you put this declare, begin, and you put the meat in between. Variable declaration. I is our variable. Now, somebody said, why didn't they use V underscore something? All right, that's what they choose to do. They choose to use whatever. But if I'm going to do that, then I would have to put it here across all of these places. Right? Let's say that's the structure we want to go with, okay? VI. Okay. I said, well, VI doesn't make any sense, right? But that's what I'm saying. That the point is you have to stay consistent, right?
Well, you can add P. It probably makes sense now. So to become
Well,
that gives us some more meaning now.
yeah, and in fact, you would do find that in some cases you find that people will do something like they will say VI num, right? And that's the format they'll follow. And then they'll say something like iterator. In this case, I'm going to iterate over something, right? And the people that do it this way, if you're used to programming languages where the data type is important, like PL SQL, then they will say, I have a variable and it's storing numbers. and the identifier I'm actually going to give to is an iterator. So anytime they step through the code, they know that the variable they're dealing with is a number. Okay. You will find that some of the legacy code you're going to see, people may follow this format. But let's walk through this code. What is this code going to do? We declare a variable and we use our colon equals 2 to assign a value 1 to it. Then we end with a semicolon, right? What are we doing in this program? We're basically going to loop through the numbers 1, right, through 10. However, the requirement is next that we shouldn't show anything. If once we exceed 10, we shouldn't go beyond it, right? So you need to define your exit condition. The point I was saying about infinite loops is that if you write any program that you're going to loop, you need to make sure that you put a logic in place to tell the loop to stop. Very, very important. So our program is saying we're going to start from 1, and it's going to get the construct loop. This is as opposed to the one that says for, right, I in 1 ... 10. This is the approach that we're choosing. You have to pick one and work with that you're comfortable with. So this approach, you declare a variable, they type loop. And your responsibility is you have to increment the counter. You say vnum iterator, I'm gonna loop, I'm gonna increment it by 1, I'm gonna output it, and I'm gonna exit whenever the iterator gets more than 10. Okay? So if we run this query, if we run this program, it's successfully executed. It's giving us some errors, okay, because I typed something wrong somewhere. Let me clear the output here and run it again to see where the error came from. All right, so to debug your program, it's actually pretty useful. It tells you where the error is. So it says error is starting at line number 4. So at line number 4, it sees a problem. And then it says, if it goes in, it says there's line number 4, column 5 within your program. So basically, 1, 2, 3, 4, column 5 within the program, it sees that this vnum iterator has to be declared. I said, okay, vnum iterator should have been declared this is very, very good because number and this I use the approach to give to us. Okay. You will see this a lot in every program you're going to write. You have to learn to read the error codes and follow them out because it will save you a lot of time, right? So here, it told me that there's something starting at line number 4. But once you hit this point, and this is very important, this is a trick I'm going to give you. Then any reference it gives you that says line number 4, column 5 is a problem, right? You now have to say, it's now going to start counting, it's going to reset the counter from here. Okay. So if we run this, if everything is good, you get a nice output. Now, let me clear. You see that on the PLC code, there's this, in the script output, there's an eraser sign, right? It says clear. So once you'll be writing your program, a lot of the output will come to this screen and you don't want it to stay there forever. So you can clear it up this way and then it goes away. It wipes it clean. And then once it's clean, you can highlight. Remember that I'm actually, in this case, I'm executing not as run a statement. I'm actually running a script because PLC calls it a running script. You'll be running a bunch of commands together. So in that case, you will run as a script. All right. So when the script runs, it's going to give you PLC call procedure successfully completed. That's what we want to see. So why did it fail the first time? The approach with programming is you should always declare your variables before you can use them. In effect, you have to tell the program that I need this space because I plan to store something there to use. So if it doesn't see you that you've requested for it and you start to reference it, it's going to say, you never declared it, so I cannot give it to you. Bug in the program. Okay. So the first thing we do is we have to declare a variable, okay, that will store this iterator, and we're going to start from 0. Now, I could have easily just done number, and that's also fine. However, when you say this, you're saying, okay, I've declared a variable and I want to initialize it to 0, right? In that approach, you actually don't even need this line, this line of the code. Okay. This line of code is not important if you do it this way. But if I hadn't done it that way, then you probably would have to. If you do it this way, then you have to do this. You say the number that yes, 0, for example. Okay. Now it's very important when you go for any of these interviews, they will give you small code like this, and they're going to test if you can read it and figure out what the output is going to be. If you're going for a pure sort of SQL job, they will test you like this. The program itself is not complicated, but they want you to be able to read it and tell them what the expected output is going to be. Even for the programs that those were web-based assessment they'll give you, right? It will be something like this too, right? I mean, a little bit more difficult, but you have to be able to put this structure together, right? So you set several output on, you declare, you begin, then you end, and you have to declare your variables. So if I have 50 variables I plan to use, I'm going to declare all of them up here. It's just a good practice to have sort of like, so somebody in their code will say variable declaration section, right? Variable declaration. Then they'll put all the variables that they plan to use in their program at the top, which is you're telling the program, hey, I plan to use all this amount of memory, so pre-allocate it for me, right? And then I'll be using it for the rest of my program. This line here, right, says, okay, I have this variable I have declared, and I want you to store 0 in it. Once you store 0, I want you to loop. This is like English in a lot of ways. This guy's okay. Begin, store some number, loop. Loop says, okay, all right, take whatever number you currently have and add 1 to it, and then print it out. And keep doing that. You exit when the number is greater than 10. So if you run this program, we're going to get 11. Now, this is as opposed to the one where we got, the first one we ran, it was 2 through 11. This one is 1 through 11. And I actually just as a test for your understanding, because you can come in an interview, why the difference between the two programs? Let me show you a bit more of this. Why is the difference? Why is it that when we first ran it, it started counting I from 2, and it ended at 11. But then when I just made a change to it, it started from 1 and it ended at 11. Why? It's not that difficult. Just think about it. Exactly. In the first case, I assigned it was 1, right? And I just changed it to 0. That's the difference. Right? So if you start off, you say, okay, start from 0. It's okay, enter the loop block. It says, okay, whatever 0, add 1 to it. So 0 plus 1 is 1, and it's printed. That's why it prints I is equal to 1. But when you change this to 1, let me clear the output so that you can see it, and you run it. Now, it starts off as 1. So when it enters the loop and you add 1 to it, 1 plus 1 is 2. So you're going to output 2. I is equal to 2. Right? Initialization of your variables is very, very important. It will throw you off a lot of times. It's most of the time when I'm debugging code, I'll say like four areas I look at. Initialization is one of the key pieces of it. I mean, typically is about the root of the problems for about maybe 20% of your cases, but you need to really initialize your loops very well, initialize your variables very well and accurately. Okay? Because imagine that you and this actually happens. Let's say you're writing code and you won't believe that sometimes you will do this. Okay, you may write code like this. Now who can tell me what would happen when we run this code? Give it a shot.
Yeah, I'm gonna be. It went out. Okay, let me see what happened. I mean, nothing is going to happen. I mean, because you're not declaring it. You don't have a declaration over there.
You lifted me and they just dropped me. So you know why? Because well, your first statement is actually most likely true. I mean, we'll find out when we run the program. But
okay,
you declare a variable, right? And you've assigned it one. And then you enter a loop. The loop says, oh, whatever value I have, add 10 to it. And remember, this 10 is a typo I made. It was supposed to be 1. But I was typing so fast I forgot it was 10. And then I ran my program and nothing comes back. And I was like, why? I will search through and step through. If it's a very long code, like 200 or 300 lines, you're like, what happened? It was working just a minute ago. Why? Control Z, Control Z, Control Z, Control Z. Right? And, but the effect of it is, or at least the import of this is, you declare a variable, you set it to 1, and then you add a 10 to it. So then it says print. So it's going to print I is equal to 11, but then it will do this check, and then it says, oh, 11 is greater than 10, so it exits out. Okay. So if you run this, it will just print I is equal to 11, and it just exits out. Let me clear out this so that I can run it and you see it very well. Okay. Notice I just printed I is equal to 11. So if you were doing this, you're like, oh, before it was giving me I is equal to 1, 2, 3, up to, why did it just do this? Right? And this is actually, I'm telling you, this is a very good practice to go for an interview where you have to code. Because they'll give you things like this and they will just make a few changes to the code to see if you can predict what's going to happen. Okay?
Yeah. Okay.
Now, again, this structure that we're looking at, you see the same structure in C#, in Python, in whatever it is, like different programming languages out there. Okay? To really understand it. And it's very different from the for approach, the for I, 1, ... 10. In this way, you are the one who's going to declare the variable. You're going to assign an initial value to it. Okay? Now, if you don't declare it and you assign a variable, it's going to fail. It's going to give you an error because it cannot assign something unless it's declared. So you should always put your variable declarations up here. And then you get into your block, okay? Here, you're the one who's defining the exit condition. You're saying that we're going to exit whenever the iterator is greater than, right? So let's do a tweak here and see what would happen. Andy, what do you think is going to happen if we do it this way? Manuel, are you there? I don't know if Manuel is still on the bridge. Andy, what do you think is going to happen if we execute this code? Understand, this is a step by step programming. This is procedural. Each line gets executed before the next. So with that approach, just think through it again and tell me what you think is going to happen. And I'm not saying what you said is wrong, by the way. And this is what happens to an interview. But I'm going to ask you, why do you say that? Mm-hmm. Right. Yep. So that's why it doesn't give you anything, because it assigned it and it gave it 11. And as soon as it got 11, it says, okay, this is the next line I'm supposed to do. The next line says exit if this thing is greater than 10. So as soon as it does this check, 11 is greater than 10. So 11 is greater than 10, I'm told to exit. So I'm out. I wouldn't even go to this line. Okay. So notice how just changing the order, right, change the output. This is what we had before. This is the one Cyril explained. It gave us 11 and it exited, right? You say, why would it even show us the 11? Because 11 is greater than 10. Well, the thing is, it did this, and the next instruction was to print it. And after it printed is when it checked to see if it could exit. You see what I'm saying?
Okay.
So, and this is very important. I mean, with programming, you're going to deal with that a lot because they call them in math. You say terminal conditions, right? When am I going to stop this, loop? When do I terminate it? Right? What are my boundary conditions? In a way, right? So, cool. All right, let's use the next 15 minutes to wrap up. And sure. No, it's iteration, yeah. So I think I don't know. I think I know what you're referring to, which is, with looping, there are so many ways to loop. Okay, we've looked at three in the documentation that we're looking at about three of them. You can find different ways people will do it, but ultimately, the key is you have to look at your business conditions. So if there's a case where I would say no matter what, the loop should do something before it exits. So in this particular case where you say enter the loop, do the increments, print something, and then check before you exit. That can be one condition, right? So for example, you could get some results set, you run some query and it gives you a million rows, right? And all you really care about is that I just want to test that the first row has some value. And if you see, just exit. It's a quick validation you're doing, right? Other practical applications with sometimes when you in fact in other languages it's called do while, which is do something first, then start your loop, right? So it's almost like I want you to assign the variable one, enter the loop, do an incrementation no matter what, and then print out before you check for exit. And like I done this situation where I flip this out. In some cases, you say, "Hey, enter the loop." Okay, enter the loop, and the first thing you're going to do is you're going to check if it's greater than 10, exit before you even go ahead and even increment. Okay, this assignment, this thing, if you play around with it, you see that there are so many things you see a lot of differences. But the key is to understand that order of execution, which is it's step by step. It's step by step. So it enters the loop and it checks the first line. Exit when vnum thing is greater than 10. What is the current value of vnum when you start, right? So in line, you start your code from begin, right? Line number 10, you say vnum is 1. You enter your loop. You say exit when vnum is this. So this is 1. Is 1 greater than 10? No. So it's going to go to the next line. Okay? So if your business requirement or the process you're trying to do requires that you test first before you even do anything, right? Then you would have to put the exit at the very beginning, right? In other words, you could get a result set and maybe all you care about is, hey, I'm testing to make sure that if the first row or first record I get, if the first name is equal to Salifu, then it means that I can go ahead and proceed, right? Otherwise, other than that, something is wrong with the query that the person wrote because you have been told that the query that the person wrote, the first record, the name should be Salifu. And so your code is saying, if I don't see Salifu as the first, I'm not going to do anything. Right? It's a validation you're doing as part of. So it's like reading the file. So when I read the file, the first line of the file is supposed to be this. If it's not that, I'm not even going to waste my time to read all the other data in the file. The program will just exit. And typically, it would exit with some output to say, hey, something is wrong with the data file I'm trying to consume. Okay. All right. Let's quickly go. Yeah, go ahead. Yeah, I mean, you could do that here. So basically, you could say if I equal, if I equal to, if I is less than 5, then you could say then, right? Right. This is what you're saying? Something like this? Yeah, you can combine that logic within the program to say, hey, I've entered my loop. And I'm going to say that let me actually do it this way. Okay. So basically, you enter your loop, right? And you would say something like, okay, I've entered this, I've initialized the variable to 1. I enter my loop. I'm going to check if it's ever greater than 10, I want to exit. So, okay, then I'm going to increment, right? So here, it starts with 1, I'm going to increment it to 2. Then I'm going to check, is this guy, is this guy less than 5? If it's less than 5, then I'm going to output this, right? Let me just iterate it so that we are consistent. Is it less than 5? If it is less than 5, then I want you to print my current number, which is equal to this, is less than 5. Else, it's more than 4, right? So let's try to see if this program will work. And if we've typed everything correctly, it should give us some interesting output here, right? So notice how it says, remember we started from 1, right? And it checks. Hold on. All right. We said it is 1, and we check, is it greater than 10? Well, 1 is not greater than 10, so I can go to the next line. I'm 13. And then I'm going to do that and say, okay, let me add 1 to it. 1 plus 1 is 2. Then, okay, once I have that, is 2 less than 5? Yes. So I'm going to execute this. Then I'm going to, once I, in the if block, once it executes, it's done. Then it's going to go to the end. And since it's in a loop, the command within a loop is to go back to the beginning. And it's okay, where am I now? The last value was 2. Is 2 greater than 10? No. So now let me do this. 2 plus 1 is 3. So now let me check 3 against 5. Is 3 less than 5? Yes. So I'm going to output that again. So you get 2 is less than 5, 3 is less than 5, 4 is less than 5. However, when we get 5, it says 5 is more than 4, right? Very, very important. I see that a lot of times when people write code, they can confuse less than and less than equal. If you want to do less than equal, then you want to do this, right? And it's you can say it's less than 6 and it's more than 5. Very, very important to understand these boundary conditions. It can really throw a lot of times throw you off, because if you just do a straight less than, it's different from a less than or equal to, right? It's not, when you speak it in English, it's very easy, but in programming, I find a lot of times people mess it up. Okay, so that's effectively what it's going to do. So if I change this sign from less than and to make it less than equal to, then now this line, which is vnum iterated whatever 5, is going to change, right? It's going to say that 5 is less than 6. Let's see if that's true. To go for a car ride. 5 is less than 6, right? Because when it gets to 5 here and it compares it, is 5 less than or equal to 5? Yes, that's true. So it's less than 6, right? Are we clear? Okay. All right, now let's try to wrap this up now. Okay. Stop presenting. And go back to the Google Chrome. Okay. All right. So to wrap up, I just want to go over, a few sections in the document, and then, the rest would be up to you guys to say, all right, let me have at it, right? So the one area that I'll talk about is a cursor, because cursors are actually where you see the power of SQL at play in your PL SQL. So a cursor, Oracle uses work areas to execute SQL statements and store processing information. So all that this means is when you run a query and there's a result set of like 100 records, when you start, Oracle reserves some area and say, hey, Emmanuel is running this query. Let me create a work area for Emmanuel. And Emmanuel's results is going to be kept there. So you run a query and the results are kept in that work area, right? There's a construct called cursor. The cursor is your programming in your PL SQL, a way for you to point to that result set. Now, see, we are used to when we run the code in our SQL developer, the result set comes in the below nicely like a grid. It's very beautiful. But what you're seeing in the grid is actually tied to a result set which is stored in the Oracle database. When you run a query and the results come back, Oracle actually keeps the results in the database for some time because it knows that you may want to run the same thing again, so it will store it temporarily so that your performance is fast. That result set, right? If you want to refer it in your PL SQL program, you use what they call a cursor. So here there are two kinds. There are two kinds of cursors. There's an implicit cursor, and then there is the explicit cursor. The difference is, in an implicit cursor, right? You've written this query: select employee first name, and you're going to store it into some variable. This is a variable that you have declared, where the employee number is 100. Okay, this is an implicit cursor. The explicit cursor is you specifically use this construct cursor. And the cursor, think of it as a variable. So you can see v underscore c1 or whatever, right? So my cursor c1 is the result of this query. This is explicit. That's the only difference. Here is implied that you're going to get a query that's going to give you just only one row back. Okay, this one. By an explicit cursor, you may get multiple rows back. So you would say, hey, I want Oracle to reserve enough memory to handle a bunch of results I'm going to get, right? And then you will do that. Now, it's very important to understand that, if you run your program and you know that you're going to get a bunch of rows when your query executes, then you have to use the right structure. So generally, my preferred approach is just use a cursor. Even if it's one row, it would work. If it's multiple rows, it's also going to work. Because the problem with these approaches is when you run an implicit cursor, you can get what example they call too many rows. Because you may think, oh, I have this query that only counts like a one row. For some reason, you deploy into production, and it's coming back with multiple rows, and that will give you an error. Okay. So generally, I would say use a cursor, an explicit cursor, right? And this query that you see here is all the queries you've been working on up to this point, right? You can write any query that you want, any structure that you want, you can run it and you put it here. And that result set that you're used to kind of shown in a grid, like what you say for every employee, the average salary, versus whatever, all that result, you can actually store it and process it line by line, row by row. You can look through that result set. And that's the power of PL SQL, because oftentimes when you get your result set in you may want to do more than just having the result. You may actually want to step through each one of them and check for certain conditions. If the first name is Emmanuel and the last name is Boer, give them a 20% increase. If the first name is George and the last name is not Boer, then those rules, you put them in that way, right? And then you look through and then you apply whatever business rules you've been given. Okay. Anonymous PL SQL block we've talked about. Let me end this by saying the anonymous SQL block, what I said was it doesn't have a name. Once you create it and you run it, that's it. But the very power of programming languages is the fact that if I write a program and it works, I don't want it to reinvent the wheel. So you have to give it a name that everybody then can use. It's almost like you create a table and you say, oh, let me create a table called Cyril, right? And I'm going to store some data in there. Now I can tell Andy, hey, Andy, I've created this table. It's called Cyril. It has data about everybody and their salary. So if you ever care for that, just go to that table, right? You've given it a name, right? So that people can refer to it. The very essence of what we've been doing, like what we just went through, the example that you, Andy, wanted to go through, we have a loop, and if it's this, do that, if it's that, right? Let's say we've tested it and it's good, and we like it, and we want to be able to use it multiple times, then we have to give it a name. Actually three very important things you have to think about in PL SQL in terms of trying to give names is the ability to create a function. So far we've used things like, NVL. NVL is a function. Oracle gives it to you to test if a value is null, and if it's null, what you want to replace it with. It's a function. Round is a function, right? Round is a function. You give a number to it and it formats it to have in the small places you want. The way you create a function is this structure. You say create or replace function and you give it a name. So think of it like, let's say if we're creating a function called round, we say create or replace function round, right? And it's going to get a set of parameters, inputs, and you declare some variables, you do some begin, and you're going to return a value. This section of it is the exception handling, right? Which is what happens if something goes wrong that we don't expect. Then we have to put some logic here to tell the user something meaningful to say that, hey, an error occurred and it occurred on this line, and it's because the cursor, you're using an implicit cursor and I got too many rows back, right? Then that tells the user something is wrong, right? So that's the exception handling piece of it. Exception handling, again, is one of the it's across all programming languages. No good programming language today exists that does not have exception handling. Okay, you need to have that. So here's an example of a function. It says create or replace function to date check null. So you give it a date, which is a string, and a format. And this job is going to return a date back to you. It takes the date and check, is the string null? If it's null, return null. Else, call this toDate function. This toDate function is actually a function Oracle has, right? And it will take the string you gave it and it will format it according to whatever you want. And that's it. Okay. Functions always give you an output back. So like if I write a function add and I say add 1 and 1, it's going to give me 2 back. However, oftentimes in programming, you don't need a function back sometimes. You just need it to go through a bunch of stuff and output something on a website, on a file or on the output window. And that's where procedures come in, right? Procedures are also the same construct. So the only difference you see is here is we create or replace procedure name. Compare that to create or replace function name. It's the same. Parameters. The only difference you see is that in a parameter list, you can actually provide default values and those sort of things, right? And in most procedures, you really want to do that. And they give an example of a procedure, and this is a procedure that will say get number of students. So you give it a course ID, and it's going to return the number of students. So the course ID is an input, right? The number of students is an output. So what it does is, okay, there are better ways to compute the number of students, right? It's a good opportunity to show a cursor in action. So the person declares an explicit cursor, which says, select student ID, student name from a table called course, where the course ID is whatever ID the user has provided it, right? And it says, go and run this, this cursor, right? It's an explicit cursor. And this is a student record type. And it would say, okay, loop, fetch, right? Fetch is actually when this query will execute. It will fetch, and then whatever output it is going to store in this record type. And then it's going to exit when it cannot find any more as it loops through your record set. The number of students, it just keeps adding, right? So basically, if you want to count the number of students in a course, and you have a table that has a student, their first name, and the course they are taking, and you say, oh, give me all the students who are taking this course, it will give you like maybe 50 people. But you don't know it's 50, right? You have to count how many came back, right? And this is what it's basically, they're showing you an example of it, right? And here they're showing them a case where if any exception happens, if the Oracle database has an issue with whatever you're doing, it's going to give you this SQL code and the error message so that it's something useful that you can tell that something has gone wrong. And package is the final part. The package is just when you have, let's say you create a program, like, Emmanuel is working on a project for his company, and his project is called Project 007, right? So he wants to put all his, the things he's going to create in a special area that nobody can mess with. So Emmanuel says, I want to create a package called 007, right? And within that package, you can put his procedures, you can put his functions. So anytime he wants to refer to it, he has to give it a fully qualified name. Remember, HR.employees is a fully qualified name for the table. In packages, is a way of you group all these things together in all these functions or procedures you've created in one area that is yours. Okay. I know time is fast spent, but I wanted to just go through this so that when you guys read it on your own, it'll become very clear. So our final session, we will create a couple of functions, we will create a couple of procedures, and it will crystallize the idea better. It should. But please take your time to go through this section of it. And guys, that's all it is to know about PL SQL. That's all there is. There are other factors and other things you need to know about it. But once you understand this basic structure we've talked about, the rest is all just a matter of just reading and just trying to figure it out, right? The exception handling we've talked about, is just if something goes wrong, what do you want to do? Oracle itself gives you its own a bunch of exceptions, like you divide it by 0, right? It will give you that error. Or it would say value error, which for folks who use Excel is there. Too many rows came back when you give it an implicit cursor, which was expecting only one row, but then too many rows came back. Or no data found. Oh, you wrote a query thinking I got data back, and I'm trying to process the data, and it says, well, there's no data. So the query didn't return anything. Do val on index is like duplicate data has been observed, and you try to insert a record, and the primary key violation has occurred. So that's it, folks. Any questions? All right, let me check to see if there's any on the chat. Okay. Emmanuel, Cyril, Andy, you guys are good? Yes.
Yeah, we just have to practice it and play around with it a whole lot too.
Yeah. I mean, the assignment.
It's interesting though, the way you have that flexibility of testing things. That's what caught my attention.
Yeah, I'm gonna give you, I think to really crystallize it before our next meeting, I'll give you a little assignment, right? Which is basically, what we've been kind of working at, right? Which is, this expression, the one I gave you, I'll send you guys an email with it, right? So it had an anonymous block, right? And I'm going to ask you guys a few questions, and then you're going to tweak the program to do the different things that I'm going to ask you to do, okay? And that should give you some exposure with it. The stuff about functions, procedures, packages, exceptions, just if you read it again, you should get it. It's not that difficult. It's just a way of organizing your code. I mean, I always say that if somebody comes, when you hear that somebody has been jailed because they stole source code from a company, yeah, typically that's all it is. They go in and find out there's a function that maybe they put together that allows them to be able to figure out how to make money off the stock market, and you go and steal it, and they come and get you because it's worth a lot of money, right? But how do they create those? They create functions, they create procedures, and then once they create these functions and procedures, they put them together in a package, right? And the package is a nice way. So, you guys, I mentioned DBMS output. DBMS output is a package, and within that package, there's a function called putLine, right? The putLine takes a string and it just outputs it to the terminal window. That's pretty much it. All right, guys. Give this apologies that it went very long, but I appreciate you guys making the time and effort to attend this, and I'll play back the recording to see if this time around it worked out better. I only heard Cyril mostly. I heard Emmanuel partially. Andy, I don't think we'll get your voice in the recording, but guys, just bear that in mind when you play back to watch it, okay? All right. Thank you, and enjoy the rest of your weekend. Okay?
Thank you very much. Thanks a lot. Yeah. All right.
Bye.